Hello and welcome. Today we are excited to have Markus from NVIDIA with us to discuss the integration of NVIDIA's cutting-edge technologies with ROS2. As robotics continues to evolve, simulators have become critical in reducing development cycles and improving overall product quality. NVIDIA has developed a comprehensive ecosystem, including powerful photorealistic simulators that play a key role in this space. Markus, how is NVIDIA currently contributing to the ROS2 ecosystem? What specific solutions or tools are you providing to enhance the robotics development experience right now?
Thanks for the question. We do many things. On the one side, we develop tools that are easily combined with ROS. So we have our simulator Isaac Sim, which has ROS interfaces. And if you want to simulate your mobile robot, your robot arm, you can then use our interfaces to connect with it. And we have that for other products as well. Like we have our Jetson computer, we have AI models, and all of that ties in nicely to the ROS community. Then on the other side, we have contributions to the ROS software side of things. So we are part of the open source robotics alliance, and we are contributing to the community. We are inviting developers to give us feedback and also bring out software such as Isaac ROS, NightROS, and contributing lots to the tool chain around using ROS. And another example is even working with partners. So we're all about partnerships and teamwork with other companies. And we have a few companies who are using our products inside of their hardware and then opening up the interfaces and inviting ROS developers to build software on top of that.
That sounds great. Yes, this community is all about networking and also collaborating and expanding the ROS development. So it's great to have you all here. So what future improvements can we expect in the integration between NVIDIA and ROS?
We are working on a lot of technologies. One for the robotic software piece, we are releasing Isaac ROS in a new version. And we have, on the simulation side, new products that are working in combination with ROS. One of them is, for example, Isaac Lab, which is an open source and modular approach for robotics simulation. In our existing robot simulator, that's more for the really high photorealistic and physically accurate simulation use cases. We have ROS1 as well as ROS2 interfaces, and there will be many more things to come. Right now we are working on the so-called 3-computer problem, where we have a combination of training, simulation and runtime, and we will announce many new things around CES and GTC conferences and early next year.
That's great, thank you. Now let's talk specifically about NVIDIA Isaac Sim. It's a helpful tool for many developers working with ROS2 ecosystem. We've been helping our clients set up simulated environments for quite some time and have been seeing how including simulators in the development cycle reduces time to market, helps detect bugs earlier, and also prevents regressions. NVIDIA offers a physically accurate simulator as part of your ecosystem. What are the key benefits of having a photorealistic simulator like NVIDIA's? How have your clients been responding so far?
Great question, thanks. So our simulation environment is physically accurate and photorealistic, and you touched on one part, but let me explain what's behind under the hood. So one part is the physically accurate that comes from our physics engine, which is then calculating all kinds of forces that objects are seeing and the robots might be feeling when they are interacting with the environment. The other part is the photorealism that comes from ray tracing and other technologies that are making everything look as it will be for people. And this can, on one side, look pretty, but a lot of roboticists don't care about this. Maybe it's a little bit more for pre-sales use cases, stuff like that. But it actually brings a lot of benefits for roboticists because you can use it to generate sensor data. And we are rendering cameras, LiDARs, and other sensors to see what the robot sees. So you can generate images and then train an AI and then use that for your robot. One example is actually shown by your team here at the ROSCon in 2024, and at your booth they can of course see here the synthetic data generation in action. So you can see a bunch of sensor data getting generated, and then used for training in AI and then detecting objects. So we can see that it's happening now. AI meets industry, so to speak. You can see that you can detect objects and you can do all the training with NVIDIA tools, and Isaac Sim is a great helping tool for that.
Yeah, absolutely. I think that one of the things, as you mentioned, photorealism is great, but one of the things that customers have been asking for is domain randomization, generating synthetic data, and being able to train models with different contexts.
100%.
Given the photorealistic capabilities of your simulator, as we discussed, companies can simulate real-world conditions with remarkable accuracy, right? How can businesses leverage NVIDIA Omniverse to teach end users how the robotic system will function in the real-world environment?
NVIDIA Omniverse and Isaac Sim can be used for many different stages in robot development. On the one side, it can be used from developers to test systems and going in an iterative way on having a simulated robot where you can test its behavior, tweak algorithms, and see how things might change in a realistic environment. Then it can be used on a, let's say, sales type approach where you can show customers how their robots would look like when they're getting automated in their factories, in their warehouses, wherever. Another point is, for example, commissioning. We see a lot of need for programming the robots in advance before going to the customer side, and we see a lot of use cases in advance, how long a robot process will take, what their behavior will be like. For example, mobile industrial robots who are using Isaac Sim to simulate their pallet jack product and testing first in simulation and then deploying it to the real world.
Here, for example, we have the example we built with Norbit and where we simulated their robot space in California, and also we show both images and it can show the photorealism is amazing. Looking towards the future, we knew that NVIDIA ecosystem plays a pivotal role in robotic space. What do you see coming next for NVIDIA in robotics?
NVIDIA is a platform company, so we bring the tools that robot developers need to build the next generation of robots. We have AI powering the development as well as the deployment of robots. And we like to build the tools for different kinds of robots. So it can be robot arms, it can be mobile robots, it can be drones, and can be many more. But where we see a trend right now as well is the case of humanoid robots, which are combining two arms at once. Then they have the locomotion, they have eyes that's seeing, then you need to do a lot of logic and reasoning to detect the environment. And this is not a self-serving focus, but instead we see a lot of technologies that are coming from robot arms that can be deployed there, and that will go back to the world of industrial robotics as well. So we see the industry moving in this direction, and this is also a great example for what we call the three computer problem. So at NVIDIA we see the need for the combination of training, simulation, and runtime, and we have computers for all of those, and we are happy to even tie into ecosystems of other companies on combining that. And we are also all about partnerships, so some of what I'm talking about might be the future, but we are already seeing it starting today with plenty of companies already using our technologies to build smarter robots.
So finally, we are ROSCon, the core and the heart of open source and robotics. So open source collaboration is key for driving innovation in robotics, right? What are top open source projects involving Isaac Sim and ROS2 that we should be keeping an eye on?
Yes, I think there will be too many to count. We at NVIDIA like to empower the open source community. We like developers building on top of our platform. There's companies that we are working closely with that are using our technology and integrating it into their robots. And this can then be used by other developers that are independent to build software on top of that. They can also contribute, of course, to the hardware, and we don't have any bounds. We have lots of open interfaces and have contributions to the ROS ecosystem. We're part of the Open Source Robotics Alliance. We are contributing and supporting open robotics. We have great partners that are also moving in this space, such as Intrinsic and many more. And we are also actively contributing to the open source software side of things. For example, with our things that make ROS better, like our Nitros library, and we have Isaac ROS, which is tying nicely to the ROS community. And one recent announcement has also been that we are bringing Isaac Lab as open source, which is our simulator for robotic learning tasks, and it's modular and flexible, and so we invite everybody to download it, give us feedback, work with it. So lots of stuff happening in open source.
So thank you for your insights, Markus. Is it your first ROSCon?
Yes, been working with many developers, but rarely been at developer conferences so far, and we'll definitely repeat this going forward.
How is it going so far for you?
Yeah, it's pretty amazing. I got to talk to plenty of smart people, and it's nice for a change to not have to lay the foundation of saying this is ROS, this is a robot, because everybody knows, everybody's a robotics nerd, and it's really lovely to see that. And I'm walking around here to the exhibit and see plenty of different types of robot demos, and here even from your Isaac Sim implementation that's used for robotics, it's pretty nice to see, and to see that everywhere here, so it's really great experience.
Yeah, it's a great community. I'm very happy that we can all collaborate.
Yeah, I'm glad.
Yes.